The National Electrical Code, or NEC, in Article 210.20a states that the ampacity of conductors shall not be less than the non-continuous load supplied. This means the current carrying capacity or ampacity of the wire must be equal to or greater than the maximum current or amperage that the circuit will draw. While a 12 American wire gauge or AUG wire has an ampacity of 20 amps, using it on a 15 amp breaker contradicts this requirement. One might ask, why should you not use 12 AWG wire on a 15 amp breaker? Firstly, overcurrent protection is compromised. A 15 amp breaker is designed to trip, that is to open the circuit at 15 amps. If a 12 AWG wire is used on a 15 amp breaker, the wire could potentially carry more current than the breaker is rated for, potentially leading to a fire hazard if an overcurrent situation occurs. Secondly, ground fault protection can be compromised. Ground fault circuit interrupters, or GFCIs, or arc fault circuit interrupters, or RFCIs, may not function properly if the wire ampacity is higher than the breaker amperage. This can compromise electrical safety, as these devices are designed to protect against specific types of electrical faults. To ensure proper electrical safety and compliance with the NEC, it is best practice to use wire that has an ampacity equal to or greater than the amperage rating of the circuit breaker. In summary, it would be incorrect to use 12 AWG wire on a 15 amp breaker for the aforementioned safety reasons. Wire sizes and their corresponding breaker sizes are carefully coordinated to ensure that the breaker trips before the wire overheats and potentially causes a fire. The NEC provides guidelines to prevent electrical hazards. For example, 14 AWG copper wire is generally rated for 15 amps, 12 AWG copper wire is rated for 20 amps, and 10 AWG copper wire is rated for 30 amps. These are common guidelines, but it is crucial to consult the NEC and local electrical codes for specific applications and dating factors. Dating factors are adjustments made to the ampacity of a wire based on factors such as ambient temperature, the number of conductors in the conduit, and other conditions that can affect the wire's ability to dissipate heat. These factors are essential to consider to maintain electrical safety. In addition to the overcurrent protection and ground fault protection issues, there are other reasons why using a larger wire gauge than necessary on a lower amperage breaker is generally discouraged. While it might seem like there is no harm in using a wire that can handle more current than the breaker is rated for, it can create confusion and potential problems down the line. For instance, someone might mistakenly replace the 15 amp breaker with a 20 amp breaker, thinking that the circuit can handle more current because of the 12 AWG wire. This could overload the circuit and create a fire hazard. Furthermore, using larger gauge wire than necessary can increase the cost of the electrical installation. While the cost difference might seem minimal for a small project, it can add up significantly for larger projects. It is generally more cost-effective to use the appropriate wire size for the intended application. Another consideration is the fill capacity of electrical boxes and conduits. Larger gauge wires take up more space, which can make it more difficult to fit the required number of conductors in an electrical box per conduit. This can lead to overheating and other problems if the conductors are too tightly packed. The NEC specifies the maximum number of conductors allowed in a box or conduit based on the wire size and the size of the box or conduit. It is essential to follow these guidelines to ensure proper ventilation and prevent overheating. In some cases, using a larger gauge wire than necessary can also make it more difficult to make proper connections. Larger gauge wires are stiffer and harder to bend, which can make it more challenging to terminate the wires at receptacles, switches, and other devices. This can lead to loose connections, which can cause arcing and overheating. Proper wire termination is crucial for electrical safety. It is essential to use the appropriate tools and techniques to ensure that the wires are securely connected and that there is no exposed bare wire. In addition to the NEC, local electrical codes may have additional requirements for wire and breaker sizing. It is essential to consult with a qualified electrician or electrical inspector to ensure that the electrical installation complies with all applicable codes and regulations. Electrical codes are constantly evolving to reflect new technologies and safety concerns. It is crucial to stay up to date on the latest code changes to ensure that electrical installations are safe and compliant. Continuing education courses and professional organizations can provide valuable resources for electricians and other electrical professionals. When selecting wire for an electrical installation, it is essential to consider not only the ampacity of the wire but also the type of insulation. Different types of insulation are rated for different temperatures and environmental conditions. For example, THHN insulation is commonly used for general-purpose wiring, while XHHW insulation is suitable for wet locations. The NEC specifies the allowable types of insulation for different applications. It is essential to choose the appropriate type of insulation to ensure that the wire can withstand the expected conditions without deteriorating. In addition to copper wire, aluminum wire is also used in some electrical installations. Aluminum wire is less expensive than copper wire, but it has a lower ampacity and is more susceptible to corrosion. When using aluminum wire, it is essential to use connectors and devices that are specifically designed for aluminum wire. The NEC has specific requirements for the installation of aluminum wire to prevent overheating and corrosion. When working with electricity, it is essential to take proper safety precautions. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Electricity can be dangerous if not handled properly. It is essential to respect the power of electricity and to follow all safety guidelines to prevent injury or death. In summary, while it might seem like using a larger gauge wire than necessary on a lower amperage breaker is harmless, it can create potential problems and compromise electrical safety. It is best practice to use wire that has an ampacity equal to or greater than the amperage rating of the circuit breaker, and to follow all applicable codes and regulations. The National Electrical Code, or NEC, serves as a comprehensive guide for electrical installations, providing detailed requirements for wire sizes, breaker ratings, and other safety measures. Understanding and adhering to the NEC is crucial for ensuring the safety and reliability of electrical systems in residential, commercial, and industrial settings. The NEC is updated every 3 years to reflect advancements in technology and evolving safety standards. It is important for electricians, electrical inspectors, and other professionals in the electrical industry to stay current with the latest edition of the NEC to ensure compliance and promote best practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also addresses specific requirements for different types of occupancies, such as dwellings, hospitals, and hazardous locations. The NEC is a complex document, and it can be challenging to navigate without proper training and experience. Many educational resources are available to help individuals learn about the NEC and its applications. These resources include textbooks, online courses, and workshops. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. These local codes may be more stringent than the NEC, and it is important to comply with both the NEC and local requirements. Local electrical inspectors are responsible for enforcing electrical codes and ensuring that electrical installations are safe and compliant. They can provide valuable guidance and assistance to electricians and homeowners. When planning an electrical project, it is always a good idea to consult with a qualified electrician or electrical inspector to ensure that the project is done safely and in accordance with all applicable codes and regulations. A qualified electrician can assess the electrical needs of the project, select the appropriate materials, and perform the installation in a professional manner. They can also identify potential hazards and recommend solutions to mitigate those hazards. In addition to ensuring safety, proper electrical installation can also improve the efficiency and reliability of electrical systems. For example, using energy-efficient lighting and appliances can reduce energy consumption and lower utility bills. Proper grounding can protect against electrical shock and prevent damage to electronic equipment. Regular maintenance and inspections can help to identify and correct potential problems before they become serious. Electrical safety is a shared responsibility. Everyone who uses electricity has a role to play in preventing electrical accidents. By following simple safety tips, such as avoiding overloading circuits, keeping electrical cords in good condition, and using ground fault circuit interrupters, we can all help to make our homes and workplaces safer. Electricity is an essential part of modern life, but it can also be dangerous if not handled properly. By understanding the principles of electrical safety and following the guidelines of the National Electrical Code, we can harness the power of electricity safely and effectively.